The last video I made showing the Dapol Semaphore on the Engage layout track circuited generated quite a bit of interest in how I go about modifying a semaphore. So I've dug into my collection of OO Dapol semaphores. These are all with broken motors ready to be upgraded to a servo. So I thought it might be appropriate to shoot a video and I'll show you how I do it. So I don't make any claims for engineering prowess here, but it is very practical and it's quite a straightforward modification. This is the HK-5330, a really small servo, and that's what I'll be fitting to the semaphore. So if we begin, let's pick a candidate. What I want is an upper and a lower quadrant. That's an upper, here's a lower. Let's use that one. And I'll work on that for this session. So I think these were an excellent idea. However, the idea of toggling a pair of wires like so to effectively toggle the output high and low was a bit, well, you could never set danger or clear, and it always annoyed me. You could only toggle it. So I've undone the ring, and somewhere in the base of this there'll be a screw. There it is, a little Phillips head screw. So if I pull that out, it'll expose the motor from the inside. Of course, I found the one that's difficult to get going. There we go. So having undone that, we can now split this. You'll see one side comes off attached to the motor and the other remains attached to the semaphore. I'll take that screw out. Now there's two wires we want to preserve in all of this, the rest I don't care for. So I pop that circuit board out. And it's these two thin wires here that run to the LED in the head. So what I'll do is I'll just clip these way down the board. Now all of this can go in the bin, along with the screws and the locating ring. So what I have left is a semaphore signal, and it's got this little spring mechanism here. As I push it up, the semaphore goes down. I'm thinking, could I use that with the spring, or shall I just completely remove it and put the servo in? I'm going to remove it. So this side of the threaded motor mount is glued. I think they use a super glue. So if I can crack it a bit, I might be able to detach it easily. There we go. Taking care not to wreck the... perfect. So there it is. It's all off, and I'm left with this little non-returning pushrod. What I'm going to do now is cut this off carefully so I don't stress the head, the arm itself. There's two schools of thought on this. This pushrod is going to need extending, and I can either go to the trouble to extend it in place, or the second option, which I prefer, which is simply to replace it. So when you nip those, they do tend to go flying. There we go. Let's pull this out. So I have an intact semaphore. That's going to look okay. The thing I like about the Dapol semaphores is severalfold. One, it might not win any scale competition prizes, but I think they're quite a sturdy, robust signal head. The LED's already in place, so I don't have to deal with all that grief. When I bought these, I think I tested it. I remember testing it several years ago, so I'm going to hope it works. We'll find out later. And they're relatively easy to modify. What I'm looking for really is lots of semaphores have arms down here like this, and people try to attach servos around it. It's going to be rubbish generally. What you want is to get the servo attached onto the base like this somehow, so it's fairly secure. And secondly, by attaching the servo directly to the Semaphore, you can set the whole thing up before you go near a layout, and then it's just a matter of dropping it in and it's got to work. Okay, before I do anything, I'm going to replace the push rod. So I've got some piano wire here, and it's fairly thin, certainly not what I'd use for operating servos on a layout. I think this is 1/2 mil. Let's find out. 0.49. If I do it a bit more, 0.48, 0.49. I'm declaring that 1/2 millimeter. About 1/2 millimeter thick seems to be fine. And what I'm going to do, I'm going to put a little bend on one end, just a slight one. I've got better pliers, these will do. So I put a little bend, and that's going to be about 3 millimeters, I'm guessing. 90 degrees, straight over, like so. Can you focus on me? There it is. And the idea being, when I've got this push rod inserted, let's have another go at focus, there we go, into here, that's just going to drop into that hole and operate my Semaphore. Now, looking at that, it's a little bit too long, but that's fine. What I wanted to do was have it a little bit too long, and then I can nip it back a little bit with the side cutters. I'm going to put my hands on both sides, because whatever I cut off is going to go orbital. So there we go. So if I drop this into the Semaphore through the top, there's some guide rods in the side, or holes, so that looks good. And it should be fairly easy to just drop this in without putting any stress or load on anything. Two things have to happen here. One, I've got to keep it in focus so you can see, and two, it's got to fit. There we go. So if I operate this now, looking good. I'm operating from the push rod, and that's looking okay. And I'm relying on the mounts here to keep this locked, assuming I don't twist it or rotate it. Yes, I think that'll be good. It'll also mean that I can pop it out if I need to do any maintenance work, but I shouldn't need to really. Okay, I think I've cut that a little too short. Let's have a go at fixing it. How do you fix it? Cut the end off. And do it again. 90 degrees ish. I'll clip that back a little, but not so much. Maybe I'll give myself about 3 millimeters. There we go. I think that's a little bit better. Hopefully it's been on camera. Let's slot that into the hole. It feels better, it's locked in better, and it's not catching on the top, so I'm happy with that. So I've got a good up and down motion. The whole signal arm is free, so we've just got the business end to deal with. And I think what I'll do, I'll snip this off about 1.5 inches, 2 inches down. I'm done with the piano wire. Brilliant. So I think I've now taught you all to suck eggs, but so far so good. Next thing I want to do is I want to put a plate on for this to sit in. So let's move the hopefully working LED lights out of the way, out the leads, and I'm going to use this little piece of balsa wood. Don't know the size, it looked about right, so let's have a go. It is 1.9 mil. It's probably an imperial size, so under 2 millimeters. Available for all good local model aircraft shops. And I need to make a hole in the middle. What have I got that would make a hole? I could use a pair of tweezers or I could probably use the push rod itself. Let's get that somewhere in the middle and hold it. Will this work? Will I regret it? Somewhere in the middle, push it through. Oops. Try not to put any pressure on the head. There we go, straight in. So I've got a guide now for this. So the idea is I'll mount this balsa like so under the base, and then I'll fit the servo to it one way or another, depending on what suits me once this has gone off. So now I've got a hole. All I'm going to do, I'm going to attach a medium or a thick super glue around here, stick that base on and give it a couple of minutes to set. Don't use a thin cyano on this because it'll just go everywhere and it won't stick very well. So I'm using a thick. I think this started life as a medium, but I've had it several years and it's gradually congealed over time. There we go, let's bend that out of the way. Gosh, I almost look like I know what I'm doing now. There we go. Some glue. Despite this being Dapol OO, I wouldn't say the end gauge size was any more difficult. It was a while when I did them, but I just seem to remember getting on and doing it. It was not much of an event. There we go. Push it on, ensure it's even, hold it down for a few seconds. Almost straight and square. Don't care. Doesn't matter for me. And stick the lid on the glue. So next time I see you, that's still working, this will be dried. Before we go any further, we need to take a few moments just to consider how we want the servo to move. So I've taken one of these small HobbyKing servos. The model number's on my website. I'll get it for you and post it into the video comments as well. But we need to consider how we want this to actually move, i.e. which end we're going to put the bounce on relative to the way this rod moves up and down. So if I have this lower quadrant semaphore here, as I pull the rod down, the signal moves to danger. So I'm going to want the lower quadrant bounce, and I'm going to want it on the when the semaphore arm is at danger and the push rod is pulled all the way down, or the piano wire. So up is clear, down is to danger. So if I have this plugged into channel 1, what I'm going to do is I'm going to select, let's do this by trial and error, mode number 3, and let's see how it moves. So if I flick a switch, let's bring it on, you can see, switch number 1, the semaphore's moved to clear, and the bounce is on this end. So if it was to be this way up, then it would be pushing up to bounce. If I attach to this side, if I go to this, I want it to not push up, I want it to pull down to bounce. So the way this is going to work then, to pull down to bounce, I'm going to need to attach the servo on this side. So it pulls down and bounces. Let's do that again. It's much easier to do it now than to have to deal with it once you've installed it and fitted it and thought, oh, now how do I make this move properly? So I'm going to fit this with this side against the balsa wood here. I think whilst I'm setting this up, there's another thing worth pointing out with the servo controller. So as I operate the servo, you can see the bounce is towards me on this side. If I end up needing to reverse it, so I'd want the bounce on this side, then instead of selecting mode 3, 1, 2, 3 flashes, I'd simply select mode 4, and now I've reversed where the bounce is. So it's cleared towards me and the bounce is now on the far side. So it is fairly straightforward, but I think it makes sense to plan which way round it goes before you actually commit this to the installation. So let's put that back, I think. Bounce towards me, and that means as I pull this, it's going to bounce up the top. Perfect. You can see the servo arm is coming below the servo itself. Now I'll probably be nipping the end off there, but when I attach this like so, what I don't want is this servo horn, the arm here, to actually hit the balsa wood I've installed. So I just need to be a little bit cautious there. And what I'll do, I'll take the outermost hole off to begin, and we'll see how that looks. But I think the overall movement, the total movement, is going to be something like from here, 2 to 3 millimeters is all it's going to need. So I'll just check that out next. So I've elected to nip a little bit off the servo horn. Let's try and bring this into focus again. So I'm going to take the outermost hole off, turn power off, and I'll just take this off here. And we'll just chamfer the edges. What I'm looking to do is allow the servo horn enough movement to breathe, so it moves properly up and down the range of motion. What we don't want is a servo horn that moves next to nothing, because the motion won't look good on the Semaphore. So the next thing I'm going to do is select the program mode, and that's just slightly south of center. So I'll just attempt to recenter this, because when I put it into program mode, it's essentially centered the servo electrically. There we go. So now I know I can turn the power off, unplug it, and as long as I don't move it, the horn is in what I would call neutral. So if I pick up my Semaphore, I want to install this with the Semaphore arm halfway between up and down, simply that when I put it into programming mode, there's no stress on anything. So that's going to go something like this. The way that's looking to me, I think I would benefit from another hole a little further in. So I'm going to go find my drill and add another hole, and possibly consider removing this. If you're anything like me, you probably don't have the right size drill for a 0.5 millimeter hole in the servo horn. So here's how I ensure a good snug fit. Take a little bit of the piano wire, cut it off, so it's about, I don't know, 1 inch. And what I'll do, I'll fit the piano wire into my drill bit. So I've got my piano wire in a drill bit, and I'll use a little screwdriver, and I'll make another hole, and I'm going for one halfway between the most inner hole and the shaft. Won't get much snugger than this. Let's see what happens. Now at this point I'm only drilling into nylon. There we go. So we've got a nice taut hole. I've added a little black dot to the servo so I know which side is supposed to be out. So with this in here, I need to recenter my servo, and then we'll go for a test fit. Centered electrically. So that's in the middle, and I want this to go so that the Semaphore arm is somewhere between clear and danger. That'll do. So I want the bend to be on that spot. So the question is, how do I put a bend in? I think I can get away with just an L-shaped bend, which will make removing it easier. Right, this will be the fun part. So that wants to be, I'm gauging that at about 4 millimeters, something like this. So if I pull that to there, and let's take this so I'm bending it outwards. Single bend, 90 degrees. Sort of. Quality engineering, hey? So I've got a single bend that's almost 90 degrees. Let's finish that off. And I'll nip this. So here's a commitment for you. I'll nip that off about there. Hold it, make sure nothing goes flying. And I should be able to slide this in through the little hole I've added that you won't be able to see. There we go. So we've got the servo horn on. Now let's bring the servo up. Let's have it on this side. And I want the horn, I want the semaphore to be somewhere between either end of motion so there's no load on it. Will do. So, how's that looking? It's not on the bottom, there's more movement. Okay, I think that'll work. Let's plug it in and see how it looks if I hold it in place. So I'll just temporarily connect this up. Let's move it into program mode first so I don't get a kick on the servo. So what's going to happen now, if I hold it here, I'll hold it with my thumb, I'm going to adjust the servo controller. There you go, now you can see what I'm doing. So I'll press the low and the high button. Let's bring it up to where we want danger, about there. And we want clear about here. Okay, let's see how it looks. There we go. Just need to take a little bit of strain off that link at the bottom. The lower quadrants generally have a little less of a bounce. There is a definite bounce there, so I'm happy with that. So what I'm going to do now is commit the servo to the semaphore. The engineers amongst you will be looking or using a nice bracket of some description. My bracket will comprise super glue, a medium strength super glue. I can hear you all screaming at me again. So what I'm going to do is manipulate this somehow. I know. Let's pull the top arm out. So I can pull this down and attach the glue. I just want a couple of drops on there, no more. One's probably enough. Two's for good measure. One, two. Okay. Line this up with the hole. happy with that, that's in. And let's push the arm through the top. So spring tension holds the piano wire in place and the servo is now attached. Let's add the servo mounting screw, some kind of posi drive, and just snip that into place. So I'm happy with the servo installation. I'm happy we've installed it and we've got no additional load, no unnecessary load on any of this movement. Everything is perpendicular, so here the piano wire is running in this axis, vertical, and the servo horn when attached is exactly perpendicular to it here, so I'm comfortable with that. So the basic servo is now installed.